Okay, yesterday we covered this diagram. So those absent class 1, please go and recap and study what is happening about the. Yeah, I will mark myself today. Your name? Heng Jin Tai. Okay. Okay, so yesterday we learned how to build this diagram. We have two systems, AON, AOA. So normally you look at a question, the question will ask you to use either AON or AOA. Okay. So if you use the wrong approach, if the question asks you to use AOA, you use AON, or you flip the sequence, the whole question gone already. Okay. So this is a very important chapter, where also my favorite area to ask you a question. All right. So yesterday we focused on AOA a lot, and then we convert AOA into diagram with 6 matrix with a magic number. Okay. Now previously we learned a few words called critical pathway. What is critical pathway? Is that you find the longest pathway or longest. Correct. So means you in the spider web that you see, you find the longest path, not longest, the path that gives you the longest time, or it will tell you the minimum project time that you need to have. All right. So we have at least 3 or 4 methods to find this critical path. So critical path is a very important things that you need to learn. So the first thing is to calculate pathway, and then you get a number. You get the longest number. Okay. Second one, you see the column at the center. If the column at the center, they are same number. For example, the one you see on the diagram with the red arrow, which is this one. If you see 0, 0, 3, 3, 5, 5, 8, 8, they are the component of the critical path. It's like a landmark, like Penang to KL. You will pass through Bentong and all this, Ipoh and all this. So this is number 2. Third one is you find the earliest finish and the latest finish. Okay, so you can see the second arrow on the screen, 3, 3, 5, 5, 8, 8, 9, 9. That is another method where you can find the critical path component. Okay, so this is early detection, and the fourth one is called slack time. Slack time, in layman term, it will be like a lazy hours, where you can sneak and be lazy, or what are the time that you can delay in case of emergency. So how to calculate slack time? You take, you can minus time either in the middle or at the last there. So for example, activity number 3, you take 4 minus 3, you get 1, 5 minus 4, you get 1. and so on. If you get zero, then that one is under critical path. Okay. Then yesterday we also find that these activities 3, 5, and 6, each one of it you have slack time 1 month, 1 month, 1 month, but the total slack time you have is not 3 months. You only have 2 months, because if you have one month spent in one of the activities, you will be out of the projects. Means you will spend more time than it should. So this is a bit summary of what is happening in the previous lecture. Okay, so I want to highlight, make sure you know how to convert Gantt chart into network. Network, you have two types, AON, AOA. Activity on the network, arrow on activity on sorry, the balik already. This is AOA, this is AOA. AOA is the arrow you have activity on. AON, you have activity in the bubble, not there. Okay. Okay. So next, we're going to learn other things already. We're going to learn statistics. So this chapter also learn about statistics, where you guess whether you can make it or not. So we will estimate time, or the rest you read. So you know the statistics, you learn about bell curve. Okay, you have Z value, and then you have 3 quadrant. Okay. So the rest you read. We will estimate 3 types of time. Most likely time, M. Optimistic time, A. Pessimistic time, B. In my slide, I use M, A, and B. Okay. Other textbook, they might give you other symbols. Okay. But what is important is that from the bell curve or from the statistic curve, you have 3 types of time. Most likely means you are able to make it like if you more than 70% or 60%, then this one here. Optimistic means is a positive projection. Pessimistic is a negative projection. So in the statistics here, you know that you have 2 quadrants. The one on the left and the one on the right. So okay, later on my side also have a little bit recall on these statistics, but I also attach the some references or additional revision material in the Canvas, so you can download and have some revision on the statistics. Right? The rest you read. Okay. Most likely is the normal analysis. Optimistic, you find the shortest. Pessimistic, you find the longest possible time to complete. Okay. Okay. First equation, you find mean. Mean A plus 4M plus B divided by 6. This equation should be familiar if you learn statistics in your statistics. Okay. A is optimistic time estimate. A is optimistic time. M is most likely. B is pessimistic time estimate. So this equation won't be given in all the assessment. It won't be given in your test, and also it won't be given in your final exam. But I expect you to know. This is a very valuable equation. You write this one, you get at least you get 1 mark. But normally, if you write this one, you don't know how to solve, or there is a mistake in the substitution, at least you get 2 marks here. 1 to 2 marks. I cannot promise you what is the marks, but minimum you write this one, you get 1 marks. If the question asks you probability, okay, you write this one, you get 1 marks. Minimum. Okay, next one is called variant. Again, statistics chapter. Variant. You take b minus a divided by 6 squared. So from variant, the sigma here, if you move the square to the right hand side, you get square root. You'll get standard variation. So if you are not clear what is standard variation, go back and open your mathematics textbook. Okay. Okay. But basically, it's just recall your statistics. This one you learned in your secondary school exam already. Nothing complex. So this is just a recap on distribution of statistics. This is a normal one that you learn in your secondary school, SPM or secondary or A-level. Not A-level. A-level you get C. Secondary school, you'll see the bottom one, which is a balance left and right. Then the top left here is a bit curved to the left. This one curved to the right. Okay. Call it beta distribution. Okay. Now again, this is a recall, a bit revision. What is statistic curve? Okay. So when you have statistic data, you can plot this data. The area below the curve, we call it probability, or what are the percentage that it will happen. Okay. So the more area you covered, for example, left and right, means it will more likely to happen and so on. So first thing, at least you recall what is the area under the graph. It's called probability. And this one, don't worry, you don't need to memorize. You'll be seeing a table, a standard statistics table. Then you just read and then use the equation to calculate. Okay. Then you have a Z sigma. Then you have this mu. You have x and time and so on. Okay. So the value of Z. The value of Z, this Z. The value of Z is x minus mu divided by sigma. Z equal to x minus mu divided by sigma. Sigma you calculate by the equation just now. Just now it's a square. Sigma is a square root. You push the exponential to the right hand side. This one is a standard variation. So this is a careless mistakes. Area of careless mistakes. So take care of this one. This one is without the square. It's a standard variation. Okay. So x is the time that you're interested in. Okay. So normally, either you find this one or you're given the x, means the project completion time. So yesterday, especially yesterday we learned about the two method, and then we learned about critical pathway. So normally what you do is that once you have the critical path time, let's say 9 months, so your x normally will be put in the critical. This one is at the center. This one is a mu at the center. Where is your center of your statistic data? Sigma is a standard variation. Okay, sigma you calculate from the square root of b minus a divided by 6 squared. Okay. So mu, again, mu is project mean time. Again, just now we learned how to find mean already. Mean is a plus 4m plus b divided by 6. Okay, this one. X is the proposed project time. So the question will ask you either what is the proposed time, or it will be given. So once you're given, you can find your Z. So these two are sometimes these are the things that we will play around. So you'll see a lot of, I think at least three equation, three equation, mean, phi standard variation, and then the Z. At least here you have 3 marks here. Okay, each one will give you at least minimum 1 marks. Okay, it depends. If question we want to help you, then each equation, general equation will be 2 marks, so 6 already. 6 over 25 is quite a lot. Okay, and then you draw the graph also. Graph normally is 2 to 3 marks. Okay, you draw where is the area that is on the left or the right. Okay. So later, Appendix A will be given. So if you download the tutorial question in the Canvas, then you'll see what is Appendix A. Appendix A will be keep on recycling in the test 2 and also your final exam. You'll see that exactly the same appendix, same Z value there. Huh? Okay. So you'll see something on this, right? So I think the previous one, either in your secondary school test, you'll see a quite similar one, right? So you refer to the value and so on. Huh? Okay. What else? Okay. So although all these you have numbers here, but we only use 0 here. Why? We are assuming we have a perfect bell curve or perfect statistic theta. We call it normal curve area. So the Z is you shift the location of your Z. This one, you shift your Z location. Okay, so you download if you have the tutorial, you have this question. So this is a project that you see is a web network. So we have start and finish. So it's a textile company. They decide to install a new computerized order processing system that link company with customer supplier. In the past, order were processed manually. That they found that it contribute to the delays in their deliveries. So they have complaints from the customers. And new system will improve the quality of the services. The company want to develop project network for installation new system. So they want to find where should they move or make arrangement. The network for installation of a new order processing system shown as below. So you can take a photo of this one. So if you lazy to copy lah, so just take, or you can just download the tutorial question. You will see the same tutorial question from Canvas. You will also see the same thing. But for at the moment, I think more faster is to take photo lah. Okay, so how many activity in this diagram? How many activities? How many activities? 11. So this is a very simple question. You look at the diagram, you know how many activities. This is what? This is all under AON. This AON diagram. AON activity on the node. Node is a bubble, a circle. So all these are node. Okay. So you look at the numbers. At the top is the activity number. Again, this is just for clarification. Normally, you won't see the destination here. Or when you draw an AON diagram, you don't need to write this one. Don't need to write. Okay. And yeah. So duration here, we have a few numbers here. Okay, duration here, you see 3 numbers, right? Previously, you only see 1 number. Here, you see 3 numbers. Okay, now you see 3 numbers already. Also, it gives you a hint. If you see a network with 3 numbers, below 1, you know it's time. Just now, there's one formula. They give you 3 types of numbers, right? Mean, optimistic, pessimistic, right? So it means that if you see 3 numbers below the bubbles, most probably you ask you this statistic question again. This is a hint. Okay, so once you find, you see the question, give you three numbers below, look a bit odd one, means it will come into the probability question. Means you die also need to use the diagram appendix already. I mean the Z value graph already. Okay. It's quite a long question actually. Long question. Okay. So it will tell you what is the activities. So this is just an explanation. Now, for example, from the start, what is installed? Number 1, activity 1, equipment install. 2, what is it? 3, what is this? 4, and what is this? Okay. All right. So the question that you see, you might not start with this diagram. You will see something like this paragraph, or either Gantt chart or a table. There are three ways of asking you question. Either you see something like this, then give you a table. Then the table will be like the one that I mentioned yesterday. You'll see activity. In this case, let's say I put in 1, 2, 3, and so on. Then you'll see time. You'll see precedence. Precedence activities. Precedence means it must wait until that one, the one that in front of the queue finish, then only can do. So this one, 1, 2, 3, 4, and so on. So normally this one don't have. The first one, we don't have any precedence. Second one, it can be activity 1. It can be normally it's 1. Then activity 3, it can be 1 or 2. Means you have to wait 1 and 2 finish, then only can start 3. Something like this. So you have 3 types of question that might come up. Either you see table, you see Gantt chart, or you see a paragraph, something like that. Okay. So the rest I don't go deep lah. So at least you already know how to extract data and then form this one. Again, the arrow always forward one. Don't draw the reverse one. No reverse in the network. Okay. And then previously we learned about dummy. AON don't have dummy one. But it can ask you definition of what is dummy. Dummy only appear in AOA. AON don't have. Okay. Okay. Then you'll see something like this. Another table. Okay. Another table. What is this one? Of course, this value will give you to you lah. So you can take a photo of this table if you haven't downloaded the tutorial lah. Tutorial chapter 5. So you're given a table, activity 1, and then you have A, B, A, and B. So if you check table, you should able to put in the numbers accordingly lah. Okay, you put in the numbers accordingly. You just copy the numbers. Like for example, like activity number 1, 6, 8, 6, 8, 10. So you just copy 6, 8, 10. Okay. The formula we did learn just now, what is A, what is M, what is B. Sometimes we will modify the table. We will not give you A, B, C. We will straight away use a description. What is A, what is B, what is M, what is B. Right? Okay. So just now I flip back the slides. What is A, B, C? Okay. M is most likely on the mean. Optimistic is your A, pessimistic is your B. Okay. So from the table, you see A and B. A is 6. 6 is the estimate that they estimate 6 months or 6 weeks. This one is week, so 6 weeks. This one is 10 weeks. So which one is pessimistic? Which one is optimistic? 6 is pessimistic. Pessimistic is yeah. Optimistic is what? Shortest possible. Pessimistic is the longest possible. Okay. Okay. The rest is just application of equation. Important is the interpretation of the numbers that you calculate. You calculate, you don't know what you calculate, so no use on. So A, M, and B. Sometimes we'll change the table. We'll put this one is optimistics, right? This is the pessimistics. Then we take this one is the mean. So you can calculate the mean time. You know how to find mean, right? Add numbers divided by 3. Oh, sorry, there's a formula here. A plus 4M plus B divided by 6. Okay. Variance here also give you the formula already. This table is very kind to you. It save you time already, but assessment, your test or final exam, this one can be blank out. So you need to apply this one. Okay, so when you do this calculation, let's say you have 10 data, or in this case 11. Be careful when you calculate. One wrong decimal place will also give you wrong numbers. For this module, minimum 2 decimal place. Minimum 2, maximum 3 decimal place. Minimum 2, maximum 3. Don't give me more than 3. Okay. Okay. So I just highlight just in case you forget during your revision. You need to calculate the mean time and variance. So most probably you will see something like this in the exam. You see this one, but you need to extend the table, calculate mean and variance. Yeah. So that you have 3 equations, so 3 marks already. Table, you calculate this one, calculate this one. Normally it's 2 marks here, 2 marks here, so it's 4 marks. So 4 plus 3, 7 marks already. Okay. Mean, yes, most likely. Okay. Most likely time, mean, most likely optimistic, pessimistic. Okay. T is the mean time, for this exercise. Okay. So the rest is just I just repeat what I explained just now. To find the T, you use A plus 4M plus B divided by 6. Okay. Then you calculate for this column. Okay. So the first one, how you get 8, you substitute the value there. Okay. So just be careful when you press your calculator. Some of your finger very big one. You will press the wrong one. Or sometimes your calculator quite old and the button is jammed. Even you press, but it doesn't input. So sometimes you only calculate the first 2, but miss out the last one. Okay, just be careful on this one. All right. Okay. Once you find the mean, you find the variance. The variance is b minus a divided by 6 and then square. So you substitute the first one. For example, you take 10 minus 6, a minus b divided by 6, you get 4 divided by 9. It's about 0.44 weeks. Again, for this module, minimum 2 decimal place, maximum 3 decimal place. Okay. You repeat the same for the rest. Okay. 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 So once we're done with the table, we start to estimate already. Okay. For each activities, once the mean time you have found already, we can determine the critical path. So the one that we learned in the yesterday class or previous class, in the bubble, the below the bubble one is a mean time. This is activity. This is the time that you learned yesterday. So the one that you learned in yesterday class, Only one number one, that one is the mean time. So you use the mean time here, you build another network, then you find the maximum time, maximum time. So there are 4 ways of finding the critical path just now before we start the class. All right. First, you calculate, you draw the network, and then you calculate how the water flow through the arrow. How many pathway you have. Right? Pathway 1, pathway 2, pathway 3, then you calculate the time. Find the longest. That is number 1. Number 2, straight away you build 6 boxes rubrics. Then you find, and then you see either the middle box is the same or the last 2 box is the same. Then they are the critical path component. Another one is you find the slack time. Slack time, those is equal to 0, 1, it will give you the critical path. Okay. So I just recap what we learned yesterday. This is the one that we learned yesterday, and then the remark here. Okay. So this one is just a recap. Identify critical path, you know already lah. Those that. Okay, this one is the web for today exercise. Yeah, we have 11 activities. So you can just have a look. Of course, this one is take from here, then you build the 6 rubrics. Okay, I'm not going to go into how to do this one already. It will take a lot of time. But when you do assessment, this one, you need to do fast a little bit because this one can kill your time a lot. Because you need to calculate one by one and so on. But it will carry a lot of marks also. So this one, I estimate lah. You draw from here to here. This one will cost you about 8 marks just to draw this one. 8 to 10. It depends on the complexity of the question. Okay, so once you convert this one into this one, can you see the critical path component? Can you see? One is not. Why? These two must be the same. These two must be the same. So this one same, this one not. This one yes. This one don't have. This one yes. This one don't have. This one don't have. Don't have. This one. Okay. Anyone else? Okay. So here if you follow the flow, you know what is the critical path. Which one? Which one? 5 and no, you see this one to here, this one to here. Oh, sorry. Yeah, okay, yeah. So it's not connected, but it's critical activities. Let me see. It's a no. It's a critical path is a longest way. The one that we see here is a critical component, the critical pathway component. So you need to see how the water flow that can go through this component. Okay. Okay. So we identified 4. Let me see. It's supposed to link. But what is important for critical path is that the one that I circle on here is that the activity you cannot delay. You cannot delay. You cannot delay. Okay, let's see how you do. So once we identify the critical path already, then we build another table. Just now you find the mean, you find the variance, you capture the earliest finish ES, EF, LS, LF, which is the 6 rubrics. You copy all the numbers. Then you calculate the slack time. Slack times, you take either this one, LS, EF, and LF. So 9 minus 8, 1, 6, 6, 0, 5, 3, 2, 21, 13, 8, and so on. Okay. Okay. So here you know that just now we determined there are 4 critical components. So 2, 5, 8, 2, 5, 8. I think something wrong with the diagram, like you see, like you say. But need to check back. I'm not sure whether there's an arrow connect 5 to 8 or not. I think something wrong with the diagram. But the idea is there, The idea is there. So you go home and see whether you check what is the wrong. But again, the idea is there. So you find the critical path activities. In this case, 2, 5, 8, 11. There are 4 activities there. So I from the diagram here, something wrong, right? What you did discover just now, something wrong between 5, 8, something, an arrow was missing or some. You might be pointing to the wrong direction. Okay, yeah. But what is important is to observe the solution steps for what we're trying to do here, right? So first we build a table, then you find the mean time, you find the variant, then you find you build the 6 rubrics, and then you find slack time, or from the rubrics you find the critical component. Okay. So compute total project variance. So you take activity 2 variant plus 5 plus 8 plus 11. Okay, so you have the variant number here. So you take number 2 plus number 5 plus number 8 plus number 11. Yeah. Again, the diagram that the network that you see there, I think there's a problem or error inside the diagram. So need to restudy the things. Okay. But the idea is there, Important is the idea for what we're trying to do. Yeah. Yes. There's a long paragraph there. Okay. Okay. Once you do that, you get a variance of the total project is 6.98 weeks. Okay, 6.98 weeks for the critical path. Okay, so once you find the variance for the critical path, okay, so you know that the variance for the critical path is 6.98 weeks. So we'll save this number. Then the question asks you, okay, yeah. So the first question is ask you to find. Let me go back to the question. The question asks you network installation. So it's to find the probability time estimate. So just to build the first example here is to guide you through how to build the table. Then you find the variance of the critical path. Then you continue with the application of data. So this example number 2. Okay. So example number 2, the company in the previous example, you define your critical path 6.89 weeks. So it means that the longest time that you spend for the projects will be 6.89 weeks. So now you want to take that data and then you negotiate with the customers. So you tell the customers that new order processing will be operates in 30 weeks. What was the probability that system were ready by that time? So now we will use the statistic problems to tell whether this will be success or not. This project will success or not. First, you find Z. Z equal to X minus mu divided by sigma. Okay, so what is that? That is a number of a standard deviation. This one you read from the table or appendix. X is a proposed project time. Mu is a project mean time. So standard variation square, variance square, variance equal to 6.89 weeks. So this one is without square, so you need to square root this number. So your standard variation is 2.62 weeks. Again, minimum 2 decimal place. Okay. So once you have that number, so for the mean 25 weeks of our proposed project completion time is 30 weeks. Okay, so this one is just to recall what we have done just now. So you'll find that our latest finish time is 25 weeks. We tell the customer is 30 weeks, we need 30 weeks. Okay, so what you do, you take numbers. X is the number that you tell customer, 30. Mu is the one that you calculate from the rubrics, from the table, from the 6-box diagram. So it's 25. Okay. Divided by 2.62, you get one number. So what do you get? Okay, 9.91 is your Z. Okay. So we start to apply statistics numbers already. The latest finish time. Here you got two same 25, 25. Okay. Of course, you look for the maximum number you have inside the table, inside the network. In this case, Chun, you have two activity have the 25 week. You look for the maximum one. Let's say this one 26, then 26. 26 and 25, you use the maximum one. Okay, now we have Z number 1.91. So you go to the table. So this one is under your appendix lah. So you have Z value, you have 0. Look for the 0 one. So 1.91, you go for the Z value, and somewhere 1.9 and 2, you need to do interpolation. So some of you, if you are not good in interpolation, please go and study how to do interpolation. Don't be surprised. Last semester, I still caught student in which semester already? Year 3? No, year 2. Year 2. They still have mistakes in the final exam. And then the whole question screw up again. Okay. So I highlight the things. So 1.9 is somewhere here. Somewhere here. So what you do? You do interpolation. We will use the 0 column value and not the 0.1. No, this one, this one is just you shift the Z location. We are using the normal curve. We start from 0. So we only use the first column. First column here. This column. Okay. So you do interpolation. You copy these 4 numbers, insert 1.91 here, put an X here, you do interpolation. This one is the correction for your the peak here. Your peak is a perfect peak. You can try to use that method if you can find the numbers. Not because I'm not statistics, so I'm not statistic guy, right? But you can try using what you learn, right? But I'm always like to use interpolation. Okay, so you interpolate, you'll get Z. 9.1 will be 4 point something, 4.4, 0.4719. Okay, so here you get 4 decimal place, so please use 4 decimal place, although just now we agree that maximum is 3 decimal place, but this chart gives you 4 decimal place, so follow 4 decimal place. Okay, you can check now whether correct or not. If you move 1.91, is somewhere behind. Right, if you say that 1.91, you should have 1.901. Here lah. Straight away check here. If your statistic teacher teach you like that, then you use this number. Okay. Can also. Can. Okay. As long as you get the numbers lah, the correct numbers. Okay. Because sometimes the chart give you until 0.9. Yeah, 3 number, then you need to do interpolation again. Yeah, but for this module, I won't give you that detail one. You don't need to go that detail. Okay. Okay, so you get your Z value 9.81, and then you get area of 0.491, 0.4719. Is 0.419 means 47% of this curve. This side. Okay, another side, another 50%. So your X value is here, 30 weeks, what you promise customer. Okay. So the probability of achieving project in 30 weeks or less is from here until here. Okay. So again, this is another half, so it's another 50% here. 50% plus the 47%. So you have 97% is achievable. Okay. Now, before you solve, you already know it's achievable, more than 50%, because from the Rubik 6 box there, you already know it's 28 days. Sorry, 25 days. So 25 days, you promise 30 days, very high chances you can complete the projects. I mean, logic thinking, but now you prove with the statistics. Statistics win. So the probability will be 97.19% that you will complete these projects within 30 weeks. This is how you solve lah. Understand? Okay. Okay, I think we stop here. Yeah, we have a 10 minutes break. So we continue 9:10. 9:10.